Hi, welcome to Physics Teacher. This video is a grade 11 physics tutorial in which I'm going to give you some tips to solve some questions involving Newton's third law. Alright, so let's look at this question. Here we have two toy wagons are tied together, wagon 1, wagon 2, by a rope as shown, rope A. Now rope B is pulling with a force of 25 newtons to the right. So let's just draw that in here. Now the mass of wagon 1 is 4.3 kilograms. So we'll write that, 4.3 kilograms. And the mass of wagon 2 is 5.5 kilograms. Now we're not considering friction in this problem. And it asks two questions. First one is, what is the acceleration of both wagons? And the next one is calculate the tension in rope A. Alright, so in my first video for force problems, I came up with these 4 steps to solving a force problem. We're going to use the exact same 4 steps. Now, if you haven't seen that tutorial, you can go watch it here. But the tricky thing is with Newton's first law is number 1. Draw a free body diagram. So in these questions, we have multiple objects. So what is the free body diagram we're going to draw? So here's a couple tips. 1, finding the acceleration. If you want to find the acceleration, you have to realize that all these objects are connected to each other, and therefore their motion is the same. So their acceleration is the same. So when you're trying to find the acceleration, what we're going to do is draw a free body diagram that encompasses all objects together. So this will be wagons 1 and 2 together. And therefore it'll have a total mass of 9.8 kilograms. That's 4.3 plus 5.5. Alright, now what forces are acting on it? I usually get a lot of students that say, well, tension in rope A, but no, tension in rope A is part of our free body diagram. They are internal forces, not external forces. The only external force acting on it here is the tension in rope B, pulling on this entire system. Alright, so let's draw that into our free body diagram. We have the tension from, I'll just write B. Now that we've figured that out, we can just continue our next steps just as we normally would. So write F net. Okay, so F net is equal to, well, we only have this tension in rope B, force B. Whenever you're doing the second step, you're doing the second step for the free body diagram that you drew in the first step. So that is our net force, FB. And I'll label that direction as positive since that's the direction of acceleration. Alright, then move on to step 3. Set F net equals to MA. So set F net equals to MA, which equals FB. Now again, what is this mass? Is it 4.3, 5.5, or 9.8? Well, the question goes back to, what is the free body diagram we're using to apply steps 2 and 3? And that's this one here. So it's the total mass, 9.8 kilograms. So we have 9.8 kilograms times acceleration is equal to that force of tension in rope B, which is 25 newtons. So now we can solve for acceleration, which will be the acceleration of the whole system, or the acceleration of wagon 1 or wagon 2. Doesn't matter, they're all the same. The acceleration is 2.6 meters per second squared. And we could just write forward. Alright, next it says calculate the tension in rope A. That's this one here. Let's continue with the same steps. Draw a free body diagram. The question is, which free body diagram? Should I do wagon 1, wagon 2, or the entire system? The entire system doesn't work out. As I showed before, the tension in rope A would be an internal force for the entire system. So we would either have to choose wagon 1 or wagon 2. Now it really doesn't matter which one you choose. You can still get the force of tension in rope A no matter what your choice is. However, choosing wagon 1 makes solving the problem easier. Why does it make solving the problem easier? Well, let's look at these free body diagrams. So for wagon 1, the only force we would have acting on wagon 1 is that force from rope A, force of tension in A. Now if we chose wagon 2, well, we have two forces acting on this one. We have the force from rope B and the force from rope A. So we can solve for the force in A from either free body diagram, but you can see it's a lot easier to work with the one that doesn't have other forces acting on it. So let's work with that first one right here. Now we'll still choose forward as our positive direction to the right, since that is our direction of acceleration. Step 2, write out F net. So the only force acting on this is Fa. So there's our net force. Step 3, replace F net with Ma. And in this case, what's that mass? Well, since we're referring to this free body diagram, it's just the mass of wagon 1, which is 4.3 kilograms. Now the acceleration we solved for in part A, which was 2.6 meters per second squared. So when we multiply that, we get the force from rope A is about 11.2 newtons, or rounded to two significant digits, 11 newtons. So that's my tip for Newton's third law. It's all about choosing the right free body diagram. For acceleration, choose the whole system. If you're looking at any internal forces, well then choose one of your objects inside the system and draw a free body diagram for that. And choose the one that has the least number of forces acting on it. However, if you do choose number 2, that can still work for us. Let me show you how. If we analyze this second one, we get F net is equal to, here we have FB plus FA. I'm going to leave FA as a vector because I'm going to assume I don't know its direction because that's the one I'm solving for. Alright then, F net is mass times acceleration, and since this is for this free body diagram, it's m2 times a, which equals FB plus FA. Alright, so let's sub in what we have here. This is 5.5 kilograms times 2.6 meters per second squared, and that'll equal FB, which we know is 25 newtons, plus FA. So if I rearrange then, this gives us 14 newtons, and then subtract 25 from both sides. That's going to equal FA, which is minus 11 newtons. So that tells us that this force is to the left, hence the negative, and has a magnitude of 11 newtons, the exact same if we were to calculate it from here. It's an action-reaction pair. I hope this tutorial helped. If you have any questions, let me know in the comments, and if it did, make sure you subscribe so you don't miss the next one.